Welcome everyone, and welcome to this video. That would be a lot of welcomes. Welcome. We're going to continue to be thinking about these multiplication strategies that we have been using. Today, we're going to come back and look at this concept of partial products. So as always, let's kind of break down what that means, right? Partial means part. So we're going to be doing things in parts. Right? And a product is the answer to a multiplication problem. So we are just kind of thinking about how is it that we can use this technique, this partial products technique, to help us multiply numbers. Okay? So we're going to get into that today. We're going to talk about a series of different things. So we'll play around again. We'll start with maybe some 2 by 1s. Again, that's the number of digits. So that'd be something like 37 times 5. We'll dive into some 2 by 2s. So that could be something like 37 times 35. And then we're going to be talking about some 2 by 3s. So that could be like 82 times 973, right? And that's what we mean by that term of 2 by 1. Or 2 by 2 or 2 by 3. We're talking about the number of digits in our problems that we're multiplying. So we're going to go through that today, thinking about partial products. Again, this whole idea is about breaking things down into parts. So I guess we might as well just take the ones we already wrote down as examples. So let's go ahead and play with 37 times 5. So remember, if we're thinking about a problem like 37 times 5 in partial products, the first thing we really want to do is be able to stack them up. Okay, so that's really the first step here, is I want to make sure that I'm stacking things up so I can look at them as what eventually will become our algorithm, right? And now I'm just going to think about how I can multiply each digit by its place value. So you're really just thinking about, and I know this is a little vague. It's kind of hard to like solidify what we're doing, but what we're doing is we're multiplying each place value. I guess I should have put a multiplication symbol in there. Multiply each place value, and we're going to break that apart. So that's the parts that we're doing. Okay, and then we're going to finalize this whole piece of work by adding the products that we find, which is, similar to the area model that we've been working on a lot. So step 1, done. I'm stacked. Cool. Next, I'm going to multiply each place value. So really, the reason we stack it is this can help us break apart where we start, because I'm going to start with my bottom number here. I'm going to start with this number 5, and that's what it is. It's a 5, right? And I'm going to multiply my 5 in the ones place by the 7 in the ones place above it. So I'm just going to multiply 5 times 7. Now I wrote that problem here so you can see it, but I'm just going to write the answer. I'm going to write the product underneath this work I'm doing. So 5 times 7 is 35. And since it's 35, I got to stack it correctly. So that's a 5 in the ones place, right? So here's our ones place, and a 3 in the tens place. Okay, so that part's done. Cool. And then I'm going to stay with this 5 because I want to make sure I multiply it by all the place values. So I took the 5, I multiplied it by the ones place. Now I'm going to take my 5, I'm going to multiply it by this 3. Now again, this 3 is not just a 3, it's a 3 in the tens place, so it's really a 30. And I'm going to do the trick we know. I'm going to say 5 times 3 is 15. 1 0 1 0, so that gets me 150, and I'm done with my multiplication. Man, there's a lot of arrows in here. Okay, let's get rid of that one. Let's get rid of this one. And you can see that this is what I've done. I took the 5 in the ones place and I multiplied it by the ones place. So ones place times the ones place. Then the same ones place times the tens place. And I'm going to get a final product by adding this up, okay? Again, one thing to note, I don't multiply the numbers that are in the same number. That doesn't make sense. I'm not going to multiply 3 times 7 or anything. That makes 0 sense. And if we add that up, I'm going to get a 5 and an 8 and a 1, and there's my answer, 185, okay? So I'm going to try to look at this some more to help us break this apart, because I do know and understand that step 2 can be very confusing with this. But this is partial products so far. And notice these were the parts. Right? I broke them apart. All right, let's see. The next one was 37 times 35. So let's go over here and do that. So 37 times 35. Okay, so I'm going to stack them, but I'm also going to try to kind of show on this other side over here, like what we're really doing. So here's my stack. And when I talk about how we're going to multiply each place value, that is going back to what we've been doing with area model, where I'm breaking apart the value of each digit. So like 37 would be 30 plus 7. And then this would be 30 plus 5. And then we have to start thinking about how we multiply all these numbers together. Like each one has to be multiplied with each one. So like this 30, I'll have to multiply it by that 30. And then this 30, I'll have to multiply by that 5. And then this 7, I'll have to multiply by this 30. And then I'll have to multiply by 5. Because that's what I'm doing. I'm multiplying each part. And that is literally the same thing I would be doing with an area model. Right? I'm going to see if I can't line these up at the same time so it makes a little sense. But if I was doing an area model, I would just do this, and then I'd be multiplying these parts by these parts. Partial product is the same. It's just that I don't use the model. I kind of just like organize my work below. So let's do that. Maybe I can build a relationship here that will make some more sense. So I'm going to start in my ones place, and I'm going to multiply the ones times the ones, which actually would be this column of 7 times this row of 5, right? It would be that problem right there. And 5 times 7, and I'll write that out here as well. Right? That's going to get me 35. So 35 goes right here because, again, it's lining up with its ones and its 10s, excuse me. So there's that. Now I'm going to stay with this 5, just like I would over here, right? But this time, I'm going to take this 5 and I'm going to multiply it by this 3. But it's not a 3, it's a 30, right? Because it's a 3 in the tens place, which, again, makes sense over here in our area model where we can see I have a column of 30 times this row of 5. And if I multiply that, that's 150, which is true. This is 150. Okay, so lined up so far. And we actually knew that from the last problem because I used the exact same digits. So we're good there because we used the ones place and we said ones times 10. But now we got to stay in this bottom number. And that's one thing to remember. You just work with the bottom number. And I'm going to start here now in my tens place. So now I'm going to start with this tens place. I'm going to multiply it by the ones place and the number above it, which would be a 7 times 30, right? Because this is a 3 in the tens place. It's 30 times 7, which would be the same thing as this row of 30 times this column of 7. And if I do that math, 7 times 3 is 21, and then a 0, so that's 210. Okay. And so we've done 3 parts, and as you can see, 1, 2, 3, and 1, 2, 3. This set doesn't really line up very well. Let me clean that up. I don't know what I was thinking there. These should be lined up just so we know what we're doing. That's why I'm going to go back and fix that. I didn't like the way that looked. So this was, come on, writing. This is 30 times 5. And then this one was 7 times 30. Okay, they're a little more lined up with their answers. Okay, so now I'm still with this 30 because I times it by the ones place. And I'm going to multiply it by this 3, which is also a 30 because it's a 3 in the tens place. So 3 times 3 is 9, and then there's 2 zeros, so that's 900. And that would be the exact same thing over here in this area model. Right? And so now, as always, like if I was doing the area model, I would add my 4 numbers together, which is exactly what we're going to do here. And the cool thing about partial products, though, is that you can already set up your addition problem, right? Notice I wrote all these answers in their place values and stack them up already, so I can just get right to work. This 5, 6, 7, 8, 9. This is actually why I really prefer partial products, because it's fewer steps and but it's the same math. I'm just organizing it different. And my organization is a few shortcuts, right? Like everything's already lined up to add. I just have to remember where to multiply each thing, right? And that comes with practice. Okay, let's finish this out. Sorry, 9, 10, 11, 12. So I would get 1,295 as my answer. Okay, so again, I'm drawing parallels to like the area model and partial products and like how we do that. So let's put that all together. So what did I say? 89 times 973. Of course I did. All right. Oh boy. 89 times 273. Okay, I'm going to do this with an area model, and I'm going to do this same problem with partial products so we can look at the differences, okay? Or the similarities, really, not the differences. Okay, so here I'm going to expand first because this helps me think about what are my values of each digit, because I'm going to multiply each digit. Okay, whereas with partial products, okay, so this is area. We'll keep that in black ink. And let's do partial over here in pink. Okay, so and then here my step would be to stack. Okay, all right. Now I'm going to come over here and I'm going to build my area model. So I have 1, 2, 3 columns. So that would be a column of 200, column of 70, column of 3, and then I have 2 rows. Okay. Now I'm going to do the same thing over here, but I'm going to set up what I'm going to multiply. I'm going to start with, oh, sorry, we said we'd keep that in pink. We're going to start in our ones place and we're going to multiply it by the ones place. So it's going to be 9 times 3. And then I'm going to do 9 times 70, right? Because now I'm going over to the tens place. And then it would be 9 times 200, which again, look, I'm gonna put the pink over here. There's the 9 times these numbers, which is what we do in an area model. And then I'm going to have to change colors so you can see the next step. Now that I've done my 9, my ones place, now that that's finished, just like over here, we'll notice there's this this row of 80. Well, that's what this is right here. It's just 80. I'm going to take 80 and I'm going to multiply it by 3, right? I'm multiplying it by the numbers above it. I'm going to take 80 and multiply it by 70. I'm going to take 80 and I'm going to multiply it by 200. So now I just have to do all these steps, and that's literally what I'm going to do. So 200 times 80. So 2 times 8 is 16. 1, 2, 3. 1, 2, 3. Okay, that's 16,000. 70 times 80 is 56 and 2 zeros. And then 3 times 80 is 240. 3 times 4 is 24. Now we have 9 times 200, so that's 18 and 2 zeros. And then we have 9 times 70, which is 630. And then we have 9 times 3, which is 27, right? So I take all these and add them together to get my answer. Well, that's exactly what we're doing over here, right? Here we are. 9 times 3 is 27. 9 times 6 is 63 and a 0, so that's 630. Again, notice I'm already lining everything up in its place value so I can add it quickly. 9 times 2 is 18, and then 2 zeros. So 1, 2 zeros, and 18. So there's 1,800. Okay, this is 3 times 8, which is 24, and then a 0. Again, notice I'm able to just line them up right away. That's the whole goal here. 8 times 9, 49, 56, and 2 zeros. So 1, 2, 5, 6. And then 2 times 8 is 16 and 3 zeros. And you'll see these are all the same numbers from over here that are over here. And to find that, I'm just going to add all of this together. So 7, 9, 10, 16, 22, 11, 12, 13, 14, and 2, and there you have it. Sorry, 24,297 partial products.